In this next example, I have a semicircle that's going to be inscribing a rectangle. So the instructions here say a rectangle is inscribed in a semicircle of radius 2. We're going to let P, the xy, be a point in quadrant 1 on the semicircle. So P is going to be over here in quadrant 1 on the semicircle. And it's going to be a vertex of the rectangle. Okay, so if I just plot that point P, it could be anywhere on that graph, anywhere on the semicircle, then it's going to be a vertex of the rectangle, which just means the rectangle is going to come down to the x-axis and across and down again. Okay, so this is a rectangle. It's inscribed in the semicircle. Semicircle means it's got to be touching, either the circle itself or the the straight line that cuts it in half. And so this rectangle, this long rectangle here, is the rectangle in question. Now, obviously, that rectangle changes shape as I move the P around, right? If I move the P up by the y-axis, we get a real tall, narrow rectangle. If I move it down toward the x-axis, we get a long, thin rectangle. And somewhere in between, we might even have a square in here. So there's lots of different shapes of rectangles, depending upon the location of P. And the location of P depends upon the value of x. X is the value you input to change the P around. Okay? So, part A here says to express the area of the rectangle as a function of x. Obviously, the area changes as I move that point around the semicircle. So, depending upon where the x value is, it's going to determine the area and also the perimeter in part B. So I need an area formula. Well, if this distance here is x, then area is area is the length times the width. Well, the length of this rectangle would have to be 2x because you have another x on the other side, right? That's your x coordinate going from the origin over. And because it's a semicircle, it's symmetric, so it's got to have the same amount on the other side. So the area is going to be 2x. That's my length. Well, here, I'll rewrite this. Area is length times width. That's the general formula. So the length is 2x, right? It's x plus x. Now the width is different. The width is the height of this here. It's the height of the function. Well, the height of the function is the y value at that point. So I could call that 2xy, right? So this is your length, this is your width. But the y value is we're not completed when we have a y in there because we want this to be a function of x alone. Well, how do I get a y value to be a function of x? Well, I look at the semicircle and I have to come up with an equation for that semicircle in terms of x, right? Y in terms of x. Fortunately, the semicircle is a function, and we know the equation of a circle is x squared plus y squared equals r squared, as long as that circle is centered at the origin. Now this has a radius of 2, so my r squared is actually going to be 4. So if I solve this for y, that way I can replace the y with a function of x, I need to subtract the x squared, so I get y squared equals 4 minus x squared. I subtract the x squared from both sides, and then take the square root. Now when I take the square root, technically I should involve both the positive and negative root, but because this is the upper half of the semicircle, I would only need the positive one. If I was looking at the lower half, I would need the negative one. Okay, so take the square root, I get y equals the square root of 4 minus x squared. That's actually the formula then for that semicircle. And that is a function then. Okay, it's a function that represents the top half of a circle of radius 2. And so now I can write my area formula by replacing this y with this weird looking square root. And so my area is simply 2x times the square root of 4 minus x squared. This function here is the area function as a function of x. And so no matter where you put x, if you plug in the x value somewhere between 0 and 2, the area of that rectangle can be found using this formula. Now the perimeter is found in a similar way, except we're going to be using the formula 2L plus 2W instead of L times W. Let me erase some of this so that I have some space to work. That top portion just describes the graph, so I've got that all, figured out. That just won't erase. There we go. Okay. So for the perimeter then, we're looking at 2L plus 2W, which the L we already said is 2x, and the W is the height, which was our square root. That's this thing, the function value. So that's the square root of 4 minus x squared. Now I could just simplify that a little bit. Perimeter would be, 4x plus 2 root of 4 minus x squared. That's about as good as we can get on that one. Okay. So that satisfies both of questions A and B, expressing the area as a function of x, doing the same for the perimeter. Both are just functions of x. X is the only variable there. Now part C says find the values of x where a and p are largest. Well, these two functions must have a maximum on them. And so what we're going to do is try to find the x value that maximizes the area on the perimeter. And it may be two different values. So I'm going to erase parts A and B here in the question. A little bit more space. Now remember, to find a maximum or a minimum, at this point we're just going to use our calculator to do that. We don't have any cool techniques to doing that right now for algebra. In fact, for these functions, the techniques we would need to find a max and min without technology would be, we'd have to know some calculus. And since we don't, we're not going to rely on that. So we're just going to rely on the technology to pull that off. So we're going to go to our y equals screen. There's our y equals screen. And I'm going to go with the area first. So I'm going to type this function in, 2x square root 4 minus x squared. Okay, so it should look something like that. I'm going to go ahead and graph that in the standard window. Ooh, it's a weird looking graph. But it definitely has a maximum. Now, we're only looking for positive values of x, right? X is between 0 and 2, for sure. And so I could really limit my window down to x values from 0 to 2, right? So I go to my window, I go 0 to 2 for my x values. And my y values, I don't know, maybe I'll just go from, well, my area is going to be positive, so 0 is a good negative or minimum value. And the y value, maybe we put in, let's see, what's a y maximum here? Maybe 4 or something. Just going to pick a number and see if it works well on the graph. It might be a little, oh, it's just about right. Look at that. Okay, I like that better. So that is from 0 to 2 horizontally and 0 to 4 vertically. I wasn't expecting it to be quite that nice. But there is definitely a maximum. Okay? And so I'm going to go, to find that maximum, I'm going to go to second, calculate. Okay, go to my calculate menu. And then I'm going to go down to maximum. And remember, it's going to ask for a left bound, a right bound, and a guess. So I just need to make sure I click on the left, then click on the right, and then put a guess in there. So I'll do that. Left. And scrolling. There's right. And back toward the center. There's a guess. There it is. So it looks like my x value that gives me that maximum is, what is that, 1.414. If I'm not mistaken, that's a square root of 2. That's a decimal for, let me just double check that. Is that right? Well, here, I'll write the value in there. So for the area, so that's 1 point, what did I say it was? 414. And the area itself hits a maximum of 4 units, right? You can see that y value there. That y value is the area because that's the area function that I inputted into the calculator. So the area, you could say that the max area is 4, right? 4 units, or 4 square units, whatever the units are. Okay, let me just double check. 4142134 square root of 2. Yeah, looks like square root of 2 has that same decimal value. So I believe that if we calculated that out, square root of 2, I think, is the value that we would end up with there. Just something I recognized. Let's do the same thing for the perimeter. So I have to input this perimeter formula into my y equals screen. So again, to y equals, oops, and I'm going to delete that. I'm going to insert, I'm just going to get the 4x in there, and the plus, delete the x, there we go. So this should be the function that you have inputted, and then I'm going to hit, now this one I'm going to zoom standard again, because I'm not exactly sure where that's going to be. Wow, that's weird. Kind of a weird shaped graph. I'm not even sure. There's got to be a maximum up there somewhere. So I'm going to try to zoom in around that maximum. So what I'm going to do actually to do that, I'm going to hit zoom, and then I'm going to hit number 2 there, zoom in, and then I'm going to scroll so that my cursor is up. You can see I have my cursor, whoops, right up there by that maximum, and I hit enter. Oh, there it is. So there is a maximum up there. Okay. So now I want to find that max. So same sort of thing, go to the calculate menu, down to maximum, give it a left bound, give it a right bound, give it a guess. All right, and there's my x and y. The x is the x position of the point that maximizes maximizes the perimeter, and the y value is the actual perimeter that's maximized. So P is max at, oops, x approximately 1.789, and then the actual maximum perimeter, so the max perimeter is approximately 8.944. Okay, so I'm just rounding these off to 3 places after the decimal. All right, so again, those max values can't really be found at this point using anything other than technology, because they do require some calculus to figure those out. But really where I want you to get comfortable with 2 things. One is constructing the formulas based upon the description of the graph, and then really using the technology to find those max and min values.